Okay, hello everyone. I am Jungang Pang from Xi'an Petroleum University, China. My title is Depositional Mode of Channel and Lobe Turbidite Deposits in Deep Lacustrine Fine, an example from Triassic Yanchang Formation, Ordos Basin, China. Objectives provide a classification scheme of lithofacies and lithofacies associations for this deep lacustrine turbidity fine, identify different deep channel and lobe subenvironments. Finally, to construct a depositional model that contains one, location and geological setting, the Ordos Basin formed a large lake environment during the late Triassic, resulting from the rapid uplift of the Qinling Range, and this was associated with rapid subsidence in the southern Ordos Basin. Our database mainly located here. These two outcrop location. The Yanchang Formation, sorry, the Yanchang Formation is composed mainly of fluvial-deltaic-lacustrine strata, can subdivided into 10 members, and the deep lake turbidites are primarily found in Chang 7, Chang 6, and 1. Background basinal setting, there is terrain, gentle terrain, and gradients in the northeast meandering river fair deltas are developed. Deep terrain and gradients in the southwest braided river fed deltas and fine deltas mainly developed. Here is the epicenter. Significance of deep lacustrine turbidites. As we know, turbiditic current flows are a key process for the delivery of sediment to deep marine and lacustrine environments. The sandstones of deep lake origin are primarily composed all kinds of sedimentary gravity flow deposits. For example, the deposits of slide, slump, debris flows, and turbiditic currents. Significance of deep lacustrine turbidites. Turbidite sandstone form petroleum, favorable petroleum receivers worldwide. From the recent history of petroleum exploration in the Yanchang Formation, we can find from year 1000 to year 1007, ever increasing sandstone receivers and petroleum receivers reserves are discovered in deep lake sightings. So in the future, deep lake area is the main target. Classification scheme of lacustrine sedimentary subenvironments. Lacustrine environments can be divided into bathymetric tracts, which may be termed deep lake, semi-deep lake, shore lake, shallow lake, lake shore, in order of decreasing water depth. And in practical, it can mean deep lake and semi-deep lake into a generic name deep lacustrine. Here is a deep lacustrine fine. Deep lake and semi-deep lake extents of Yanchang Formation. From the distribution of deep lake deposition of the Yanchang Formation Ordos Basin, we can find the migration of deep lake extent southwest, then to northeast from Chang 9 to Chang 7, and then Chang 1. Here are some examples of deep lake deposits. We can also find the migration of deep lake deposits in this profile. Lithofacies classification scheme of deep lacustrine fine. using a physics classification scheme adapted from that of Mel. These physics classes are identified for the Yanchang Formation, and we also compared the lithofacies with unite in Bouma sequence. For example, SMT due to debris flow deposits, SM due to rapid deposition of high density turbidity current, and so on. This phases type of deep lacustrine fine of the Yanchang Formation. Some examples, for example, SH, SM, SMT, Bouma sequence, FD, and so on. Depositional mode of submarine fine and architectural elements. In this deposition mode of submarine fine, we can identify canal or slope channel, submarine fine, basin plane. In submarine fine, we can identify all kinds of channels and lobes, architectural elements of submarine fine. The system of Yanchang setting can compared with sand-rich system and partially mud sand-rich system, so mainly composed of channels, lobes, and partially slumps and slides. These physics association and architectural elements of deep lacustrine fines. We identified the following architectural elements: mass transport deposits, slope channel turbidites, channel left turbidites, lobe turbidites, and so on. Here is an example of deep lake turbidites fine in member Yanchang 7 in outcrop. First one, mass transport deposits mainly composed of a mixture of sand and mud characterized by multiple deformed bodies, commonly occurs in the proximal proportion of turbidity fine, including various mass transport deposits, for example, ball and pillow structure, deformational structure, a mixture of sand and mud, and so on. Slope channel turbidites mainly developed in slope setting, mainly record turbidity flow, slides, lumps, and debris flow deposits. The single sand bodies is relatively thin, less than 2 meters. We can identify this sand-dominated channel field characterized by a concave base and flat and sharp top composed of sandstone, and alternately, this mud-dominated channel field fully filled with mud deposits. And there are different types of soil class, load class, and reef of mudstone class in the slope channel deposits. Obviously, strong erosion for this slope channel. And channel left turbidites, channel field turbidites, superimposed medium and thin fatty sandstone over fine and thin upward faces trends, massive or normal graded bodies, vary so much due to high density turbidity currents, local sporadic debris flows. Left turbidites fine grained sediments, mainly due to lower density turbidity currents. Here is the example in outcrop interbedded with channel field turbidites and left turbidites. The following are characteristics in detail for this channel left turbidites, mainly composed of interbedded channel turbidites, sandstone, and leaf and mud. For example, B, C, E, and show the fanning and thinning upward trend, and I can show load structures strip up mud chips. lobe turbidites, mainly composed of thin-bedded and medium-bedded sandstone, interbedded with mudstones, causing and sinking upward trend can be identified under the common Bouma sequence and some soil casts, for example, load cast, float cast. Here is an example of deep lacustrine finds composed of channel turbidite, lobe turbidite, and sheet turbidite. And based on core and log data, we can characterize the lithofacies association, lateral and vertical variability. Here is an example. And the lithofacies association.
You have 2 minutes left. You have 2 minutes left.
Okay. Okay, thank you very much. Lithofacies association and sandstone thickness isopatch map, we can find this profile mainly composed of vertical stacked channel turbidites and lobes, and channel turbidites are common and with significant thickness and lateral extent, and lobes are not async. Depositional mode of deep lacustrine fine of Yanchang Formation, the extension and orientation of sand bodies, and these sediment gravity flows are primarily triggered by collapse. Conclusions in future work data from wells will be used to further characterize and infer the geometry of channel and lobe elements. That's all. Thank you for your attention.
Thank you very much for this example of lacustrine, presenting us with the example of a lacustrine submarine fan. In your abstract, you mentioned that the fans in lakes may have characteristics that are not always comparable with the fans that are deposited in ocean basins, and that's because the variation in lake level can change quite rapidly compared to normal sea level changes. Perhaps I missed this, but did you point out from in your presentation some features of these characteristics?
Do you ask me the characteristic for this lacustrine deep lacustrine fine compared to submarine fine?
That's right. Yeah. Are there certain characteristics that we should be aware of that you want to mention right now, or?
Yeah, good questions. At present, we identified the lithofacies and the lithofacies association and the architectural elements, for example, slope turbidite, slope channel turbidites, channel level turbidites, lobe turbidites, and sheet turbidites, and I think most the architectural elements similar to that in submarine fine.
Okay.
With a smaller scale, I think. Okay, thank you.
Yeah, thank you very much. Okay, thank you for your presentation.